How does accelerator mass spectrometry improve radiocarbon dating? Have you ever wondered how scientists determine the age of ancient artifacts? One of the most fascinating methods is radiocarbon dating. Today, we will discuss how accelerator mass spectrometry, often referred to as AMS, enhances this process. So, how does accelerator mass spectrometry improve radiocarbon dating? First, let's talk about sample size. Traditional radiocarbon dating requires samples that can weigh several grams or even tens of grams. In contrast, AMS can accurately date samples as small as 20 to 500 milligrams. This is particularly important in archaeology, where artifacts are often rare and fragile. By needing less material, AMS minimizes the destruction of precious items. Next, let's look at sensitivity and speed. Conventional methods relying on detecting beta particles emitted during the decay of carbon-14. This process is slow, as only a tiny fraction of carbon-14 atoms decay in a reasonable time frame. AMS, however, accelerates ions to high energies and counts carbon-14 atoms directly. This means it can detect about 1% of the carbon-14 atoms in a sample, compared to less than 0.1% with traditional methods. This increased sensitivity not only speeds up the process but also improves precision. Another advantage of AMS is that the smaller sample size and higher sensitivity allow for more selective chemical pretreatment. This is essential for removing contaminants that could skew results. For instance, modern carbon contamination can lead to inaccurate dating. By working with smaller, well-prepared samples, AMS enhances the accuracy of the dating process. From an archaeological perspective, these improvements mean that AMS can be applied to a broader range of materials. Tiny fragments of bone, charcoal, or textiles that might be impossible to date using older methods can now be analyzed. This capability allows archaeologists to gain more information from their excavations without damaging valuable artifacts. However, it is important to note that AMS does have limitations. It still requires calibration against known-age samples to account for variations in atmospheric carbon-14 over time. AMS is generally reliable for samples up to about 50,000 years old. Archaeologists must also be aware of potential sources of error, such as sample contamination and instrumental uncertainties, when interpreting results. In summary, accelerator mass spectrometry improves radiocarbon dating by allowing for the analysis of much smaller samples with greater sensitivity and speed. This makes it especially suited for archaeological artifact recovery and analysis, where preserving samples and achieving precision are essential.